Hello guys, and welcome to another video. On this video we'll be looking at physical and chemical changes, starting with physical change. Physical change, guys, by definition is a change in which the form or state of matter is altered. So in a physical change, we change the form or state of matter, but one substance is not transformed into another. Okay, the starting and ending substances are chemically identical, they do not change. That's what physical change is. It is when we have a change in the state of matter, but the substance is not altered, or rather one substance is not altered. Okay, that's what physical change is. And as you can see, that the starting and ending substances will continue to be the same. Nothing will change. I will show you examples of this situation. And then these are the core principles of physical changes. We have the conservation of mass and atoms, and you can read, and the matter is neither created nor destroyed in terms of this conservation of mass and atoms. This means that the total mass as well as the absolute number of atoms or molecules will remain constant throughout the process, and we will also have a particle rearrangement. This means that physical changes rearrange particles. They do not change the state of matter, but they simply rearrange particles and often alter the shape, volume, or macroscopic appearance of a substance without shifting its internal chemical structure. Okay, reversibility is when we have physical changes that are generally reversible using physical methods, and those methods can be things such as cooling water vapor to recover liquid water. All right, another one is intermolecular forces and macroscopic nature, but I don't want to dwell too much on these ones, guys, and I'm gonna move on now to the ones that are most crucial. These are crucial, especially the conservation of mass and atoms, but there'll be a video I do on this one. The other ones are just for you to know, and in fact, let me highlight the key ones, but not that much important in terms of this video for now. These are the key ones that you need to focus on, but in terms of this video, I'm not going to be focusing on these, and they don't really form part of our lesson today. We have types of physical changes. This is where things get really important now, guys, so please make sure that you understand here. All right, so we have types of physical changes. The first type is the phase change. Remember what we said about physical change. We said physical change is a change in which the form or state of matter is altered. All right, so the first type of physical change is phase changes, and this is driven by the absorption or release of thermal energy. The absorption or release of thermal energy. If the kinetic energy of particles increases sufficiently to overcome the intermolecular forces holding them together, a change of state, which is from solid to liquid or liquid to gas, occurs. This situation of intermolecular forces being overcome, guys, has to do with the topic we did under kinetic molecular theory. I hope you remember that. And this means that when we change our phases, we'll move from solid to liquid, and we know that in solids we should have strong intermolecular forces, but as we move to liquids and to gases, the intermolecular forces keep on getting weaker and weaker. And then we have another type of physical change, and it's called conduction. What is conduction? Conduction is the transfer of thermal or electrical energy through a material. While the internal energy states of the materials shift, their fundamental chemical identity and molecular structure do not change. So if we look at conduction, you will realize that conduction is simply the transfer of thermal or electrical energy through a material. Thermal means what? Heat. We're basically talking of heat energy here when we talk of conduction. Conduction has to do with physical changes and also the phase change. Now we move on to another key part of this lesson, the separation and recovery methods, or reserving, dissolving. So we have different types of changes that will take place here, and those ones are going to be called the reversing, dissolving. So dissolving a solute into a solvent creates a solution, and this is indicated by the abbreviation AQ. If you see AQ, this means that your substance is a solution, and we say that it's an aqueous solution. This AQ means aqueous. This is a physical process that can be reversed using the following physical separation techniques. And the first separation technique is evaporation. So when we use evaporation, we use it to separate a solid solute such as salt from a liquid solvent such as water. Energy is supplied to vaporize the liquid element completely, causing the pure solute to precipitate out. And then we also have distillation. Distillation is a technique used to separate liquid mixtures based on differences in their boiling points. And we have two types of distillation. The first one is simple distillation. This one involves a single vaporization condensation cycle, whereby the mixture is heated to the boiling point of the more volatile component, which transitions to the gas phase, moves through a condenser tube, and is recovered as a liquid in a separate container. You don't really have to understand these details, just understand what is simple distillation. And it's a type of distillation that involves a single vaporization condensation cycle. Okay, don't stress about the other parts. So I'll just highlight the key part in terms of this definition, what you have to focus on or stress about. Yes, you should know this stuff, but just also focus on knowing the definition of simple distillation. Okay, this is the example thereof. Another type of distillation we have is fractional distillation. Fractional distillation utilizes fractioning column to conduct multiple vaporization condensation cycles. So the differences with simple and fractional distillations is that simple has a single vaporization condensation cycle, whereas fractional distillation has multiple vaporization condensation cycles. I hope you notice that, guys. Those are the differences. Okay, and we move on to another type of reversing. We have filtration. Filtration is a method designed to separate heterogeneous mixtures composed of solids and fluids, liquids or gases. And then we also have paper chromatography. This one is a diagnostic method used to separate mixtures into their component parts based on varying structural affinities to two phases. There's the stationary phase and there's the mobile phase. The stationary phase is an absorbent material that remains fixed, and the mobile phase is a suitable liquid solvent or mixture of solvents that flows through the stationary phase, carrying the components of the mixture along at different rates. Okay, that's what mobile phase is. And here, guys, I just want you to mainly know the different separation methods, okay, or the recovery methods, separation or recovery methods. I want you to know that we have, and these are under physical change. It's evaporation, distillation, we have filtration, and we have paper chromatography. Just know those ones. The other things are there for you to know, but the main things are those different separation methods. Okay, we are done with our physical change, Now we move on to the chemical change. What is chemical change? Chemical change is a process where substances interact to break old chemical bonds and form entirely new chemical substances with distinct chemical properties. Okay, this is another crucial definition that you have to know. I'll highlight it in yellow just to show you that this one is worth knowing. Okay, the definition of physical change is a must know. The definition of chemical change is a must know, because they can ask you those on the exam. So I'll repeat the definition of chemical change. It is what? It is a chemical change, it is a process where substances interact to break old chemical bonds and form entirely new chemical substances with distinct chemical properties. And these are the core principles of chemical changes. Firstly, chemical change has to do with what? Intramolecular disruption. What does this mean? This means that unlike physical changes, the intramolecular bonds between atoms within the particles are broken during a chemical change and new chemical bonds are established. Hence we say chemical change. We have a change whereby we will have old chemical bonds being broken so that we form new ones. All right. Then another principle is the conservation of mass. This one is another crucial one, but I will do a video on this one. It's not for this lesson. But the conservation of mass is whereby matter is conserved and the total mass and the total number of specific atoms there before the reaction, which are the reactants, remain exactly equal to the total mass and number of atoms after the reaction, which are the products. Then another crucial thing here is that one of the properties of physical change is irreversibility. This means that chemical changes are fundamentally irreversible by simple physical separation means. So the differences between physical changes and chemical changes are that physical changes can be reversed, whereas chemical changes are irreversible. Okay, no physical methods can actually reverse chemical changes. That this one is also key. Okay, that's another key difference there. And then we have other things here like microscopic indicators, and we also have catalysts there. And yeah, these other things, guys, I don't want to talk about because they don't really form part of the syllabus and this lesson. But you can take the notes and have them on your book or wherever you write your notes. I'm not gonna discuss these too much. They are not really about our lesson. Okay, these are the ones that I want us to talk about, the types of chemical reactions. The first one is decomposition reactions. This is very crucial, guys. This one normally comes up a lot on the exam. So they say here that a chemical reaction in which a single complex compound breaks down under specific energy inputs to form two or more simpler substances. That's what a decomposition reaction is. It is a chemical reaction in which a single complex compound breaks down under specific energy inputs to form two or more simpler substances. These reactions are fundamentally endothermic. Decomposition reactions are basically endothermic, okay? And they require an input of energy in the form of heat, light, or electricity. Endothermic means that, guys, these type of reactions absorb energy. They need energy for them to actually happen, and that energy is in the form of heat, light, or electricity. Okay, now the example of how a decomposition reaction works, because remember, keyword here is that we have a single complex compound in a chemical, in this type of reaction, right? And it breaks down into what? Into two or more simpler substances. So this means that decomposition reactions will have one substance, and that substance will be broken down into two or more substances. Are we clear on that? And it has to be a complex It has to be a complex compound, guys, that will be broken into two or more simpler substances. I hope you understand that. And this is the example of that. You see here, I have AB which reacts to form A plus B. So AB is that single complex compound, and it is broken down into two simpler compounds. I had AB complex compound, and now it has been broken down into A plus B. A plus B are the simpler compounds. Okay, so this is a decomposition reaction. I hope you understand that, guys. And we have types of decomposition reactions, but what you need to realize, regardless of the types of decomposition reactions, is that we have one complex compound and it breaks down into two or more simpler compounds. The first one is spontaneous decomposition. This one happens naturally without external intervention if a compound is highly unstable. Spontaneous means that you don't need to be pushed, so it doesn't need to be pushed for it to happen. But look at the situation here. See, here we have a complex compound, and then it breaks down into two compounds. Check what's happening. On the left I have one, but now when I go to the right I have 1 and 2. I have two compounds, and they were all formed from one compound. That's what a decomposition reaction is. Even with this example, you see here that on the side of the reactants I have one compound, and then it's broken down into two simpler compounds. Okay, I hope, guys, you notice that. And then we have other ones, other types of thermal decompositions, and they work the same way. I'm not gonna really go through the definition for now, but okay, let me do that. So thermal decompositions are triggered explicitly by the application of heat energy. So for these ones to happen, they need heat energy, and we see again here that this CuCO3 is what our one complex compound, and it breaks up into two simpler compounds. Do you see that, guys? And this triangle here means that we are having heat energy break up this complex compound. Then we have another decomposition, photochemical decomposition. But like I'm saying, decomposition, whatever type it is, it works the same way. So photochemical decomposition is driven by light absorption in photosensitive compounds. So this one needs light energy for it to take place. But again, we have one complex compound, and it breaks down into three. In this case, it has broken down into three compounds, 1, 2, and 3. You see that it has broken down into three compounds, whereas it was one initially. It was one compound broken down into three compounds. Okay, and then there is another thing that you need to understand, and it's called electrolysis. Electrolysis is driven by passing an electric current through a liquid or solution to force decomposition. So this electrolysis, guys, can help us to have the ability of having a decomposition reaction, and it needs what? It needs electric current. Okay, that's what it is. We have another type of reaction. Remember, the first one is decomposition reaction, whereby we have one single complex compound which is broken down into two or more simpler compounds. Okay, guys, now we are looking at the synthesis reaction. So a synthesis reaction is a chemical reaction where two or more simple chemical species combine directly to build a more complex product. So this means that with a synthesis reaction, we will have a reversal of this situation. Basically, it's an opposite of a decomposition reaction. Whereby our reactants will be more than one. It will be two reactants or more, and they will react to form one product. Okay, and another crucial thing is that these reactions which happen to be synthesis, or rather which happen to be synthetic, let me use that word, are exothermic. So the differences are that a decomposition reaction is endothermic, it absorbs heat, whereas a synthesis reaction is exothermic, it releases heat. See here they say it releases energy into the surroundings, sometimes violently. Okay, now this is the example of a synthesis reaction whereby we have two reactants A plus X, and they react to form one complex product, which is AX. Do you see that? Decomposition, you have one reactant which reacts to form two products. Synthesis, you have two or more products, two or more reactants which form one complex product. I hope that makes sense, guys. Now these are our examples. We have the synthesis of water, we have O2 and it bonds with H2, and you see that these are in a gaseous phase. G means the phase is gaseous, and they form one product, and that product is water, H2O, and water is in a liquid phase. When you see this energy being added, it means the energy is being released. If the energy was on this side, you would say the energy is being absorbed, but because it's on the right, it means the energy is being released, because synthesis reactions are exothermic, they release energy. Okay, then we have other situations. Here we have C plus O2. C is in a solid phase, and oxygen is in a gaseous phase. They react to form carbon dioxide, which is also a gas. We have sulfur in a solid phase bonding with oxygen in a gaseous phase, and they react to form sulfur dioxide, which is in a gaseous phase. Then we have phosphorus, and it's in a solid phase, and it bonds with oxygen in a gaseous phase, and they react to form phosphorus pentoxide. Okay, guys, I hope you get how these work. Okay, there are other types of chemical change reactions, guys. There are other types of chemical change reactions. These are those reactions. Some you will learn about in grade 11. Some you'll probably learn about at university. The first one is displacement, and this one is a more reactive element which replaces a less reactive element inside a compound. This is how it looks. We have precipitation. An insoluble solid product forms when two clear aqueous reactants interact. This forms a distinct precipitate block. We have a neutralization. An acid reacts with the base to neutralize and cancel out their respective properties. It produces a salt and water. I think you learned about this one in grade 9. You'll also learn about it in grade 11. We have a combustion reaction. This one is an exothermic reaction where a substance reacts rapidly with oxygen, and significant temperature spikes releases light and heat. This one you'll also learn about in grade 12. And then we have redox reactions, a chemical process involving an explicit transfer of electrons between reactants, simultaneous reduction and oxidation. This one you will learn about in grade 11 and 12, but you don't have to stress about these ones much. The ones that you must know are your synthesis reaction and your decomposition reaction. I hope, guys, you found this lesson to be valuable. Please just make sure you understand the definition of physical chemical change and their differences. The differences are that a physical is a reversible reaction, or rather physical change is reversible, whereas chemical change is irreversible, and their definitions will also be crucial. Okay, also know your types of reactions: decomposition and synthesis. I'll see you guys on the next video. Please give this one a like. Thank you. Bye.